These are the answers to your homework. If you'd gotten your homework off the internet, off my website, then the answers were at the bottom of it. Questions on 1, 2, or 3?
It kind of have a question on 3.
Okay.
How does secant become a non-negative?
If you remember your even odd functions, secant and cosine are both even. So that means when the negative's inside, that's the same as just there being no negative. So you can just drop it.
Oh, okay.
If it was any of the other functions besides cosine and secant, then you would have to move the negative to the front.
Okay, I see. Thank you.
No problem. Any others? There's 4. Well, most of 4.
How did you get the cosine squared, like the sine x over cosine squared plus 1 from all?
Alright, so I changed everything from whatever it is now to sines and cosines, and then I distributed 1 over cosine. So 1 times sine is sine, cosine times cosine is cosine squared, and then 1 times cosine is cosine, cosine times sine would be cosine sine, but then you have a cosine on top and a cosine on bottom. So these two will cancel, and you're left with just a 1 over sine. Alright? And then you get a common denominator by saying, for these to have the same denominator, this one needs a sine, whatever you do to the bottom, do to the top. This one needs a cosine squared, so whatever you do to the bottom, do to the top. So you'll end up with a sine squared plus cosine squared, which is nice because that equals 1.
Keep number 6.
Are we okay up till here with 4?
Thank you.
Can you go back? 5's down here still. I haven't gotten there yet. 6 we're not quite finished yet. This was just a blank sheet of paper when I was working. I worked right across the top and then 4 fit here. But I couldn't fit 5 there, so I did 5 right below 4.
That's like my struggle.
I can find them all, so it wasn't a huge deal to me. Alright. So then the last step, that you guys could see down to here on number 4. So the last step is just to split them and then recreate your fraction with the cosecant on top. You guys want me to do number 6?
Yeah, I think someone wanted you to do 5 too.
Yeah, I haven't exposed all of 5 yet, so that might be helpful once we all get to see it. But for number 6, the left-hand side is definitely not as ugly as the right-hand side. So we're gonna mess with the right-hand side. And there's nothing I can do with these two by just multiplying by like a cosine or a sine to make them all completely go away. So what I did was I used the conjugate. And by conjugate I mean same functions, different middle sign. So cosecant plus cotangent on top and bottom. So our new top is cosecant plus cotangent. And on the bottom, when I FOIL this out, this ends up just giving me cosecant squared minus cotangent squared because the middle two terms will cancel. That should happen every single time you use conjugates. Of the 4 terms that you get, the middle two should cancel. So then, if you remember our trig identity song, 1 plus cotangent squared,
Sorry,
you're good.
1
1
plus
plus
cosecant.
cotangent squared is naturally paired with cosecant squared in the end. So I can take cosecant squared and replace it with 1 plus cotangent squared. Well, that's nice because now my cotangents cancel. And I'm left with just a 1 on the bottom,
Oh,
which now I have
Cos-
cosecant
and
plus
cosecant.
cotangent over 1 is the same as just saying cosecant plus cotangent, which is what the left hand side wanted.
Hold on, so just to make sure, cotangent, cotangent squared plus 1 is equal to cosecant squared,
Yes,
and then tangent squared plus 1 is equal to secant?
yes.
Okay,
So cotangent squared plus 1 goes with cosecant, and then tangent squared plus 1 goes with secant.
I remember that.
The codes go together.
I remember that, because that funny song taught us.
And there's number 5. So first thing I did here was turn everything into sines and cosines. And then on top, I have an unwanted cosine in a denominator. On the bottom, I have an unwanted sine in the denominator. So when you have those unwanted denominators, if you multiply everything by the denominators, they will go away. So on top, the cosines cancel, leaves me with sine. The cosines cancel again, sine times sine is sine squared. On the bottom, the sines cancel, leaves me with cosine, and then nothing cancels, so I have sine cosine. And then I went ahead and did my GCF, which if you look here, they both have a sine, so I can pull out a sine, that leaves me with 1 plus sine. On the bottom, they both have a cosine, so if I pull out a cosine, that leaves me with 1 plus sine, which now I have the same thing in top and bottom, so those cancel. Sine over cosine is tangent.
wait, so why did you choose sine times cosine?
Because I have this denominator here, and I have this denominator here. And we hate fractions within fractions, they're just a disaster to work with. So if I can multiply top and bottom by those unwanted denominators, they'll go away. And now I'll go back to a normal fraction, which is bad enough as it is, and not have a fraction added to a fraction on top of another fraction. And that's just,
No more.
no more, I don't want it.
No more.
Yes.
Like this on the place.
I don't think I have any with division in it
Okay,
like this.
thank you.
Alright, are we good with the homework?
How'd you get the 1 plus sine x on the bottom where it says,
They both have a cosine.
no, that's right now.
I know, they both have a cosine. So I pulled out a cosine, I undistributed cosine. Because if I were to take cosine and redistribute it back in, I would have cosine plus sine cosine, which is what I have right here. Are you okay with that? Any other questions?
Well, it's only pretty fancy, but
No, they're the same sign, so they can cancel. When I say things like you can't cancel. When I say things like you can't cancel subtraction or addition over division, yes, this is addition, but what's going on out here is multiplication. And I can cancel this whole piece because I have multiplication, and I'm undoing multiplication with division. What I mean by you can't cancel subtraction or addition with division is you can't say this and go, oh, so I have 1 minus sine, and that's my answer. Because this really is, like, that's a no-no, you can't do that at all. What that should have become, this splits into 1 over sine x minus sine squared x over sine. So if you really wanna cancel, you have the choice to split it and then cancel. But if you were to just cancel it the way we just did beforehand, you end up with no fraction. There still should have been a fraction. It still should have been 1 over sign as well. What this is saying is I had 2 separate fractions that have the same denominator, so I can create 1 fraction with them. All right? What's up? Okay. Go ahead and hit stop on that.